Hi everyone, welcome back to the channel. In today's video, we will be discussing some of the most commonly asked interview questions for a generative AI developer role. I will explain the concept in a simple and interview-friendly way to help you prepare with confidence. So, without wasting any time, let's get started. The first question is, what is generative AI? Generative AI refers to AI models capable of generating new content such as text, images, audio, video, and code based on patterns learned from the large data set. Unlike traditional machine learning, which predicts or classifies, generative AI creates new content. Example include ChatGPT, Claude, Gemini, Midjourney, and GitHub Copilot. Next question. Explain large language models. Large language models are transformer-based neural networks trained on massive data sets using self-supervised learning. They predict the next token based on the previous context. Example include GPT-5, Claude, Gemini, and Llama. Explain the transformer architecture. Introduced in 2017 through the paper Attention is All You Need. It is the foundation of modern large language model. It converts input text into embeddings and adds position encoding to preserve the order of words. Uses multi-head self-attention to understand the relationship between all words in a sentence simultaneously. It processes the data through feed-forward networks with residual connection and layer normalization for efficient learning. Predicts the next token using a linear layer followed by a softmax function enabling text generation. Advantages are parallel processing, faster training, better long-range context understanding, and high scalability for models like GPT, Llama, Gemini, and Claude. The next question is, explain self-attention. Self-attention enables each word in a sentence to focus on the most relevant words regardless of their position. Each token generates three vectors: query, key, value. So the query of a token is compared with the key of all other tokens to calculate attention scores. Softmax converts these scores into probabilities which are used to assign importance to each token. The weighted value are combined to produce a context-aware representation of the token. Benefits are capture long-range dependencies, understands the context more accurately, and enables parallel processing for faster training. Example, the animals didn't cross the road because it was fair. So here, the self-attention correctly understands that it refers to animal, not the road. The next question is, what is prompt engineering? The prompt engineering is the process of designing and optimizing prompts to guide large language models to generate accurate, relevant, and high quality responses. It involves providing clear instructions, context, constraints, and examples to improve the model's output. Effective prompts reduces ambiguity, improve the consistency, and enhance the response quality for different use cases. Common prompting techniques include zero shot, one shot, few shot, enough thought, and role-based prompting. So it is widely used in chatbots, content generation, coding assistant, document summarization, translation, and question answering. Best practices: be specific, provide context, define the expected output format, and iteratively refine prompts for better results. Example, write about AI. Explain generative AI in 5 bullet points with real-world examples suitable for beginner, clear and specific. So what is retrieval-augmented generation, in short form, RAG? Retrieval-augmented generation combines the information retrieval with a large language model to generate accurate, context-aware, and up-to-date responses. Instead of relying only on the model's training data, RAG retrieves the relevant document from a knowledge base. Example, it may be a PDF, it may be from database, SharePoint, website, before generating an answer. The retrieved information is added to the user prompt, enabling the LLM produce grounded and reliable responses. Typical workflow involves, so first first we will go to upload the document, then it will be a chunking, and the next it will be embedding, and after that it will go to the vector database, and from the vector database it is going to search for the similarity words, and next it will come to the LLM again, and the response we are going to get. So what are the benefits? It reduces the hallucination, provides domain-specific answers, keeps knowledge current without retraining the model, and improves response accuracy. What are the use cases? So uses cases are enterprise chatbots, document Q&A, customer support, legal and healthcare assistant, and knowledge management system. So here in the right side, I have given the RAG workflow. So first we are going to upload the document. The document will be divided into chunking or smaller boxes, smaller things called chunking, and that will be converted into a numerical representation called embeddings, and that will be stored in a vector database. And from the vector database, so it is going to we are going to have a similarity search, and based on the user query, it is going to search for the relevant context, and then it will be fed into the LLM, and from the LLM, we are going to get the accurate response. So this is the actual workflow of RAG. So the next question is, why retrieval augmented generation? So LLM have limited knowledge and may not include the latest or organization specific information. It reduces the hallucination by rounding the responses in retrieved documents instead of relying only on the model's memory. It provides real-time and domain-specific information from PDFs, databases, websites, SharePoints, or internal knowledge bases. No need to retrain or fine-tune the model whenever the documents or business data changes. So it also improves the accuracy, reliability, and explainability by generating responses based on relevant retrieved context. So if you use a RAG, it is ideal for enterprise applications such as customer support, document Q&A, healthcare, legal, finance, and internal knowledge system. So here I have given the difference between if you use a RAG and if you don't use a RAG. So in the left column, you can observe if you don't use a RAG, what will happen? It uses only a pre-trained knowledge. And if you use a RAG, it retrieves the latest and relevant information. So again, if we don't use the RAG, it may generate hallucination. And if we use a RAG, more accurate and grounded responses. It will not create hallucination if you use a RAG. And next, if we don't use a RAG, it cannot it cannot access the private company data. But if you use a RAG, it can use enterprise documents securely. And if you don't use a RAG, it requires retraining for new knowledge. And if you use a RAG, knowledge base can be updated instantly. So I have given the clear difference between the RAG. So if you use a RAG and if you don't use a RAG, what happens? So you can go through this. So the next question is difference between fine tuning and RAG. So fine tuning. So it updates the model. If you use a fine tuning in LLM, what happens is it updates the model weight using a new training data, and it requires the retraining. So here I have highlighted in a bold point. So it requires a retraining, which is time consuming and expensive. The third point is it is best for changing the model's behavior, style, or domain expertise, and the knowledge becomes part of model after training. And also it updates. The updates require another fine-tuning cycle. So the fine-tuning is applicable for only one cycle, and if you want any further updates, again, so we need to do it again once again. So use cases are custom writing style, domain adaptation, and code generation. When it comes to the RAG, if you use a RAG in LLM, what happens is it keeps the model unchanged and retrieves the external knowledge at runtime. And here, in case of RAG, no retraining is required and simply update the knowledge base. And it is best for providing the latest factual and organization specific information. And if you use a RAG in LLM, what happens is knowledge remains in external document or a vector database. And also, the new documents can be added instantly without retraining. So use cases here are documents and documents Q&A, enterprise chatbot, customer support, knowledge assistant. So here you can observe some of the important things are fine tuning is equal to teach the model how to respond, change the behavior. Okay. So RAG, so retrieval augmented generation, it gives the model what to respond with. So retrieve the relevant knowledge. So many production AI applications use both fine tuning for specialized behavior and RAG for accessing up-to-date enterprise-specific information.